A black hole is not a hole in space, but a place where gravity becomes so extreme that escape stops being possible. If you drift toward one, nothing dramatic happens at first, because the danger begins long before your body fully understands it does. From far away, it might look beautiful, a dark sphere surrounded by light, quiet, elegant, and almost impossible to fear. But that beauty hides a boundary called the event horizon, the point beyond which nothing, not even light, can return. Cross that boundary, and the universe behind you keeps existing. But for you, every path now leads only inward. You would not hit a surface or fall through a tunnel because a black hole is not built like anything familiar. Instead, you would keep falling into a region where space and time are being bent beyond ordinary human intuition. To an outside observer, you would seem to slow down near the edge, fading and freezing as the gravity grows stronger. But from your own perspective, the fall continues, and the black hole becomes less like an object and more like destiny. And once you begin asking what happens next, you are already standing at the edge of the strangest place in physics. The event horizon is the invisible boundary around a black hole where escape stops being a future option for anything at all. It is not a wall, a shell, or a surface, but a limit written into the geometry of space-time itself. Once anything crosses it, every possible path through space and time points deeper inward, never outward, toward the universe behind it. This happens because the escape speed beyond that boundary becomes greater than the speed of light, and nothing can outrun that. From far away, you would never watch someone cleanly cross the horizon because gravity distorts time and slows their image. Their signals would stretch, redden, and fade, making them seem frozen at the edge even while they continue falling. But for the person falling in, the crossing might feel almost normal, especially near a supermassive black hole with weaker tidal forces. There is no alarm, no flash, and no cosmic sign telling you the line has been crossed in that exact moment. Yet after that point, the black hole no longer surrounds you from outside. It defines the future you are trapped inside. The event horizon matters because it is the last place where physics still lets us describe the fall from outside. A black hole looks dark because once light crosses the event horizon, every possible direction leads deeper inward. Light still moves at the fastest speed in the universe, but inside that boundary, speed is no longer enough. The problem is not that light becomes weaker, it is that space-time itself bends every path toward the center. From outside, stars behind the black hole appear stretched, duplicated, and warped by the gravity bending their light. This bending can create a glowing ring because light from behind the black hole is curved around its edge. The black part is not empty darkness. It is the region where light paths can no longer return to your eyes. That is why black holes are found not by seeing them directly, but by watching how they distort everything nearby. Gas and dust outside the horizon can glow brighter than galaxies as they heat up before disappearing forever. So a black hole is both invisible and surrounded by some of the brightest violence in the universe. The darkness is not absence. It is gravity becoming so powerful that even light loses the right to leave. Near a black hole, gravity does not only pull harder, it also changes how time itself passes compared with regions farther away. This effect is called gravitational time dilation, and it means clocks deeper in the gravity well run slower than clocks far outside. If you watched a clock falling toward the event horizon, each tick would appear longer, as though time were stretching under immense gravity. Light from that clock would also redden and fade, because the black hole steals energy from anything trying to climb a way outward. To a distant observer, You would seem to slow almost to a stop, hovering near the horizon without ever clearly disappearing completely. But from your own perspective, your heartbeat, your thoughts, and your falling motion would still feel normal as long as tidal forces remain tolerable. In fact, if the black hole is supermassive, you might cross the event horizon before feeling anything extreme happen to your body. While your own time continues, the outside universe could appear strangely accelerated as distant clocks race ahead compared with the seconds you feel. So the black hole creates a split in reality, one version seen by you and another seen by those watching from afar. Near the horizon, time does not break, but it becomes so distorted that two observers can no longer agree on what is happening. As you fall deeper, gravity becomes stronger at your feet than at your head, creating a deadly stretching force. This difference is called tidal force, and near smaller black holes, it can become fatal before the event horizon. Your body would be pulled longer and thinner, not because gravity pulls evenly, but because it pulls unevenly across distance. Scientists call this spaghettification, a strange name for one of the most violent effects in the universe. At first, the stretching might feel like pressure, but deeper inside, it would become impossible for matter to remain intact. Bones, organs, atoms, and eventually molecules would be forced apart as gravity overwhelms the forces holding matter together. In a supermassive black hole, this process may happen later after crossing the horizon because tidal forces are gentler at the edge. But deeper inside, even a supermassive black hole cannot protect you from the growing difference in gravitational pull. Spaghettification is not a monster attacking you, it is geometry turning your body into a path gravity can stretch. Inside a black hole, destruction does not need impact, because the shape of space itself becomes the weapon. The honest answer is that we do not truly know what happens deep inside a black hole. Our best equations describe the outside extremely well, but beyond the horizon, direct observation becomes impossible. Anything inside cannot send information back, because every signal, particle, and ray of light is trapped inward. That means the inside is not hidden by distance. It is hidden by the structure of space-time itself. According to general relativity, everything falling inside moves toward a future where the center becomes unavoidable. But the word center may be misleading, because inside a black hole, space and time no longer behave normally. What we call inside might not resemble a place at all, but a direction that every possible future must follow. Some theories suggest crushed matter, others suggest quantum effects, hidden information, or physics we have not discovered yet. This is why black holes are not just objects in space. They are laboratories for the limits of knowledge. The deeper we imagine falling, the more we reach the edge of what human physics can explain. At the center of the black hole, our equations predict something called a singularity, where density becomes impossibly extreme. A singularity is not a normal object because it represents a place where our current physics stops giving clear answers. According to general relativity, matter falling inward is compressed into a region so small that curvature becomes infinite. But infinity in an equation often means the theory has reached its limit, not that reality truly becomes infinite. This is where gravity and quantum mechanics collide, and neither theory alone can fully describe what is happening. Some scientists think the singularity may be replaced by unknown quantum structure instead of a true infinite point. Others suggest black holes hide information in ways that may force physics to change at its deepest level. The singularity is terrifying because it is less like a place and more like a question physics cannot yet answer. If you could reach it, every familiar idea of size, direction, time, and matter might lose meaning completely. At the singularity, the black hole becomes not just darkness, but the boundary of human understanding itself. Because black holes hide their interiors, people often wonder whether they could be doors to somewhere else. In science fiction, they become tunnels through space, shortcuts across the universe, or gateways into other realities. Physics does allow mathematical ideas like wormholes, but that does not mean real black holes are safe passages. A wormhole would require extreme conditions, exotic matter, and stability we have never observed in nature. Most black holes we understand would crush, trap, or stretch anything entering long before it could reach another universe. Some theories suggest the information inside black holes may not be destroyed, but encoded in ways we barely understand. Others ask whether a black hole could connect to a white hole, a hypothetical region where matter only escapes outward. But these ideas remain speculative, because no signal from inside a black hole can return to confirm them. The mystery is powerful because black holes sit exactly where imagination and physics collide. They may not be doors, but they force us to ask what space, time, and reality actually are. To understand black holes honestly, we must separate what physics predicts from what imagination adds beyond the evidence. We know black holes exist because we observe stars, gas, and light behaving as if invisible gravity is controlling them. We have even imaged black hole shadows, not the holes themselves, but the glowing matter surrounding their dark regions. We understand event horizons through general relativity, and the theory has survived many difficult tests with remarkable precision. But what happens at the singularity remains unknown, because our equations break where quantum effects should become important. Wormholes, white holes, and hidden universes are fascinating possibilities, but they are not confirmed destinations inside black holes. Hawking radiation suggests black holes may slowly lose energy, but the information problem remains one of physics' deepest puzzles. Scientists are still asking whether information is destroyed, hidden, transformed, or somehow preserved at the horizon. So the truth is both clear and mysterious. Black holes are real, but their deepest interiors remain beyond direct knowledge. The closer we study them, the more they reveal the difference between knowing something exists and understanding what it truly is. A black hole is not only a cosmic monster, it is a mirror showing the limits of what human knowledge can reach. We can describe its gravity, measure its effects, and see the glowing matter dying around its edge. But the moment we ask what truly happens inside, physics begins to speak in uncertainty instead of certainty. The event horizon is not just a boundary in space, it is a boundary in what information can return. Beyond it, the universe may continue in ways our equations suggest, but our instruments cannot directly confirm. That is why black holes are terrifying, not because they are empty, but because they hide answers perfectly. They remind us that reality may be deeper, stranger, and less complete than the maps we have drawn. Every question about them leads to a larger question about space, time, matter, information, and existence itself. Maybe the inside of a black hole is not just a destination, but a warning about the edge of understanding. Because the darkest place in the universe may also be where the next truth is waiting to be discovered.